Alright, so now that we've learned about piecewise functions, we are going to be evaluating the piecewise function. We're going to do it 3 different ways. And in this video, we're going to evaluate a piecewise function from an equation. So we've already had a picture of what a piecewise equation looks like. And we know it's different than what equation we have seen because of the domain restrictions. So you've got to pay close attention to that, okay? So first, I want to review, what does evaluating mean? So sometimes we get confused with what math rules sometimes say, like what does simplify mean? What does evaluating mean? What does solve mean? So what does evaluating mean? Evaluating means, I've got 3 different things here. It says to substitute a number for each variable and perform the arithmetic operations. Sorry, got sequences on my mind. And then it also means to find a numerical value for an expression. Then to find the value of an expression when the variable is replaced by a given number. So really what all 3 of these have in common is you're replacing that variable with a number and you are going to get a numeric answer. So all your answers for when it says to evaluate a situation, your answers should be in numerical form. Okay, it shouldn't be in a 3x plus 2 form. It should be 6, 12, 9. Okay, it's going to be a number. It's always good to know what your questions are asking you so you can make sure your answers are in the proper format. Okay, so evaluating means we are going to plug a number into a variable and get an answer back. Now, you are used to seeing when evaluating, they would say, hey, you've got this 3x plus 2. If x is 3, what's y, right? You take it and you would replace the x with the 3 and you'd get 11, okay? But now we're going to be doing a lot of function notation. Okay, so evaluating with function notation, it's just a little bit different how it's written, okay? But it's just knowing what that function notation is. So function notation is where you have f of x, okay? Inside, that is your x value, okay? And so this is my x value, and it's wanting me to find my y value. So I'm giving you what is x. Now tell me what y is by plugging x in, okay? Now, you have 3 different equations to choose from here that make up this piecewise function. So you must pay attention to your domain restrictions, okay? That tells you where to plug this number into, okay? So 0. Is 0 less than 3? Yes, 0 is less than 3, so I'm going to plug it in. Now, when I plug numbers in, I use parentheses because I feel like it helps you out and helps you make less errors, okay? So if you look, this negative is part of the equation, so it's going to be negative. We got the x, now replace that x with 0, and then minus 4. You can use your calculator or Desmos, and my answer is negative 4. So f of 0 equals negative 4. Okay? All right, number 2, f of 12. So it's saying when x is 12, what is y? Is 12 less than 3? No, it is not. Is 12 in between 3 and 10? Nope. Is 12 greater than 10? Yes. So we're going to replace this x right here with 12. So we're going to say 120 divided by 12 plus 5. Well, that's going to be 15. Okay? So when x is 12, y is 15. Okay? And this is just me showing you my work. All right. Next one is 3. It's saying when x is 3, what is y? Now, if you look, we've got 3 in 2 different places. Okay? You have to pay attention to the inequality. Is 3 less than 3? No, 3 is not less than 3. But is 3 greater than or equal to 3? Yes. You're got to find, these are your hot points, okay? You've got to find where it equals 3 if it's a hot point. And it equals 3 right here. So I'm going to plug 3 into this x right here. Now, when you're doing squares, the quadratic, it's so important to use parentheses, especially for negative numbers, okay? So I'm going to plug 3 in, and I get 3 squared minus 7. So 3 squared minus 7 is 2. So when x is 3, y is 2. All right, now 10. So again, 10's a hotspot. All right, so you've got to make sure you choose the one that it can equal 10. It cannot equal 10 down here, but it can equal 10 right here. So we're going to plug 10 into this equation. Whoops. So we have 10 squared minus 7, which would be 93. So when x is 10, y is 93. All right. Last one for this one is 5. Okay. 5 is not a hot spot, so let's read the inequalities. Is 5 less than 3? Nope. Is 5 in between 3 and 10? Yes. So we're going to plug 5 into this x. And I've got 5 squared minus 7. Okay. And that's going to give me 18. All right. So it's the same evaluating you've done. It's just you have to pay attention to who you plug your x in. You can't just plug it into anybody you want to. Okay. All right. Next one. Next one, we only have 2 equations to look at. Okay. So we're going to do the same thing. I'm giving you x. Tell me what your y is by determining which domain fits that x value. Okay. So first one, x is 0. Is 0 between -1 and 2? Yes, 0 is between -1 and 2. So I'm going to plug 0 into here. And I'm going to say negative 0 plus 1 squared. And that's going to give me, now, you got to make sure, if you get confused, make sure you use your calculator because order of operations is important. So it's going to be -1 here. So when x is 0, y is -1. Okay? All right. Oops. All right, so the next one is 4. Where does 4 fit into here? Is 4 between -1 and 2? Nope. So we can't use that equation. Is 4 in between 2 and 5? Yes, it is. Now, this brings up an equation. I want you to flash back from Math 1. This is a constant, okay? And a constant has no variable. So that means you have nothing to plug in to. So a constant, that is just going to be your answer. From any number between 2 and 5, your answer will be 4. Okay? That is the y value for every number that satisfies this domain. So when x is 4, y is also 4. There's nothing to plug in. You do not multiply, you do not add, you do nothing. You just keep that number as is. Okay? All right. So next one, when x is -3. Is -3 in between -1 and 2? Nope. Is -3 in between 2 and 5? No, it's not either. Okay, so if you have nowhere to, if there is no domain that satisfies this x value, that means this x value does not exist on this graph. So your answer would be does not exist. Okay, you just can't make something up. If it doesn't fit this domain, it just doesn't work. Okay. All right, 10. Is 10 in between -1 and 2? Nope. Is 10 in between 2 and 5? Nope. So 10 also does not fit this graph. So it's going to be another D and E. Okay. Now 2. 2 is a hot spot. You got a 2 here. You got a 2 here. Can it equal 2 in any of these equations? No, it cannot equal 2. So again, this is going to be a does not exist. Okay? It's just that simple. If you do not see it, it cannot satisfy any of these domains, it is a does not exist. All right? All right, next one. So we got another one with 3 equations. So let's do some more. So this is saying when x is 17, what is y? Well, here my domains are a little bit different. It's telling you where it can equal something, and then it's telling you where it doesn't equal something. So I just want to talk about them. So the first one is saying that my only x value, t is where x is, so you can say t or x. But the only number I can plug into this first equation is 17. I cannot plug in any other number but 17. Same thing for the second equation. I can only plug in 19, nothing else. Now the last one says that t cannot be 17 or 19. So that means that t can be any number in the universe but 17 and 19. Okay? That is what that means. You'll see a lot of this one on Delta Math if you're using Delta Math. So the first one is saying when x is 17, we'll say t, excuse me, when t is 17. Well, when t is 17, I plug it into the first equation. That's the only place it can equal 17. So I'm going to say the square root, I'm going to say the square root of 17 times 17, and that's going to give me 17. Okay? All right, 2 is saying when t is 19, well, t can only equal 19 in this second equation down here. So we're going to plug it in there. We're going to say negative 34 divided by 19. And 34 divided by 19 is going to give me a nasty little number. So you have to pay attention to what it tells you to round to. We're going to do 2 decimal places. And we're going to say it's negative 1.79. Okay? All right, the third equation is 3. Well, I told you, not the third equation, sorry, the third question. I told you the only place that can do anything but 17 and 19 is the third equation. Okay, so any number you see that's not 17 or 19, you're going to plug in that third equation. So 3 is not 17 or 19, so we're going to plug it in there. 23 minus 3 gives me 20. Okay? 4, x is 10. Well, last equation, 23 minus 10 gives me 13. And number 5 says when t is 5, well, the only place t can equal 5 is this last equation. And so again, we're going to say 23 minus 5 and get 18. Okay? So sometimes the domains look a little different. And that's what that means when you have the not equal. It cannot equal those two numbers, but as you can see, it can equal any other number but those numbers. Okay? So now we're going to do some piecewise with operations. Okay, so it's the same thing we just did, except now we're going to be adding and subtracting our answers. Okay, and you're going to see these on the DCA, you're going to see these on the EOC. Okay, all right, so we're going to work over here on this one, on the left-hand side. So I want to find each one of these and then add the answers together. So first we're going to find f of negative 4. Well, the only place it can equal negative 4 is right here. So I'm going to plug it into this equation. Now notice that is a negative on the outside. And we've talked about with transformations that when you have a negative in front of a variable, it means opposite whatever you plug in. Okay? So that means we're going to plug in a negative 4. So f of negative 4 is going to be 4. Okay? Next is negative 2. Well, it can only equal negative 2 in the second equation, and it's x minus 3, so we're going to say negative 2 minus 3, which is going to give me a negative 5. And the last one is 1. Well, the only place it can equal 1 is right here, so we're going to plug 1 into that last equation and get 1 squared minus 2, and that's going to give me negative 1. I'm going to add all these numbers together, okay? I'm going to say 4 plus negative 5 plus negative 1, and I'm going to get negative 2 as my answer. So we're doing the same thing we've been doing. It's just we're just combining those parts together and just adding them together, okay? Now sometimes you can subtract, which is in B. So now we're going to find each one of these. So f of negative 3. Let's erase all this. So negative 3 is not a hotspot. So negative 3 is greater than negative 4 and less than negative 2. So we're going to plug that into the first equation. So we're going to say negative 3, which is going to give me a positive 3, minus 0. Where does 0 fit? 0 fits in the second equation because 0 is between -2 and 1. So we're going to say 0 minus 3. So that's going to give me a -3. Plus, where does 3 fit in? 3 is greater than 1, so 3 goes here. So that's going to be 3 squared minus 2. So it's going to give me 7. So we're going to say 3 minus -3 plus 7. And I get 13 as my answer. Okay. So what I want you to do now is I want you to pause the video. And when you pause the video, I want you to work on the right-hand side one. It's exactly what we just did. Okay, you've got the screen to the left that shows you my work. So pause this video and work on this, okay? All right, so I hope you paused the video and I hope you worked on it. Let's see if you got it right, okay? So A says f of 5. Well, the first equation, it can equal 5. And remember, a constant, you plug nothing into a constant. A constant, it is just that. So f of 5 is 2 plus, all right, -2. -2 is a hot spot, so we got to pick the one that it can equal. It can equal right there. So we're going to say -2 times -2 and get a positive 4. And 3, well, 3, you cannot plug 3 in, can you? So 3 does not exist, so we'd have nothing to do with that one. So we're just going to say 2 plus 4, and we get 6. So that one was a little bit tricky. Okay. All right. B, it says f of 6. So f of 6 is going to be greater than 5. So its answer is just 2. Minus f of 0. Well, 0 is in between -2 and 3. So we're going to say that. We're going to say -2 times 0, which is 0. And then -3. -3 is less than -2, so we're going to plug it in there. Now, this is where I can tell if you use parentheses or not. Okay? This equation, you need to use parentheses when you are squaring a negative. So if you got this one wrong, it is probably because you did not use your parentheses right. Or you just didn't use them. Okay? So please use your parentheses, and you should have got -7 here. So we're going to say 2 minus 0 plus -7, and my answer is -5. So if you didn't get -5, go back and see if you used the parentheses or not, okay? So basically when I use a negative, I always put a negative in parentheses, okay? Because it can mess some stuff up. All right, so I hope you got those two right. All right, so the last one is going to be an actual question from the EOC, okay? This is where you are evaluating, but you're evaluating and you've got two piecewise functions. So you have to pay attention to, this is the h of x function and this is the g of x function, okay? You have to make sure you're plugging it in. These are two different functions. So what is the value of 3 times h of 2? So this is saying whatever h of 2 is, I want to multiply it by 3, okay? So h of 2 means I have to use the h function. Then I look at the domain. It can equal 2 on that last one. So I'm going to plug 2 into here. I'm going to do a little side work, and I'm going to say 4 times 2 plus 1, which is going to be 9. But this equation says 3 times h of 2. Well, h of 2 is 9. So I'm going to say 3 times 9 and get 27. Okay? The next one is my g function. So I need to come to my g equation. And where can it be 1? Is 1 less than 3? Yes, 1 is less than 3. So I'm going to plug 1 in here. And I'm going to say 1 squared plus 2, which is going to give me 3. This one also had a number up front, so it's saying you need to say 4 times whatever g of 1 is. And g of 1 is 3, so we're going to say 4 times 3 and get 12. And then 27 plus 12 is going to be 39. Okay? All right, so that is it for evaluating piecewise with the function, the equation. All right? Thanks, guys.